This is I am Frihat, and today I will be talking about kinetic energy and potential energy on a roller coaster on a smooth track. Now, as the information is already given, the mass of the roller coaster is 100 kilograms, with the velocity at point H also being given at 2 meters per second. The first question asks us to find the kinetic energy at point H and the potential energy at point H, with potential energy equaling mass times gravity times height, and kinetic energy being half times mass times velocity squared, both being measured in joules. I will be demonstrating and answering these questions. At point H, the kinetic energy, as is already given, has a mass of 100 kilograms. So half times 100 times the velocity, which is already given at 2 squared, should give us a total of 50 times 2 squared, which is alternately 200 joules. The potential energy at point H should be quite simple. We should follow the formula of mass times gravity times height, which should lead us to the mass being 100 times the Earth's gravity, which is universally known as being 9.81, times the height, which is shown here as 10 meters. The final answer, as demonstrated on my calculator, should be 10 times 9.81, which is the gravity, times the mass, times the mass of the roller coaster at 100, which should give us a final of the potential energy being 9,810 joules. Now let's fill this out on the answer sheet real quick. 20 joules with the potential energy being 9,810 joules, which should give us a total energy of 9,810 plus 200 joules to add all the energies, all the forms of energy up to give us a total energy, which should end up as 9,810 plus 200, which gives us 10,010 joules. At A, we should follow the same path of total energy as in an energy conversion. The amount of energy stays the same from the start at point H to the end at point A, or if you want to say point X. At A, the rule in physics of minimum potential energy equals maximum kinetic energy applies, where the potential energy is 0 as the height is 0, which automatically means the kinetic energy is max, which automatically means that the kinetic energy in this scenario equals the total energy. So the potential energy in this scenario is 0 joules as the height is 0, with the kinetic energy being 10,010, in other words, the total energy. As the energy conversion was brought out between point H and point A, the total amount of energy stayed the same, which is the point of this demonstration. At point B, it is brought to us that it is the middle, which automatically means that between 10 and 2.5, between 10 and 0, the height will be 5 meters, halfway through the smooth track, with the potential energy being mass times gravity times height. The scenario would be 100 times the Earth's gravity, which is 9.81, times the height at 5 meters, with the mass being 100. Let's calculate this on the calculator real quick. 100 times 9.81, which is the gravity, times the height at 5 meters, which gives us 4,905 joules. Now, simply, to find the kinetic energy in this scenario, we need to deduct the potential energy from the total energy of 10,010 to find out the kinetic energy, which should leave us with 5,105 joules. This till now it's straightforward, and now we end up at point C, where the height is clearly shown as 2.5 meters. To find out the potential energy, we follow the same formula of mass times gravity times height, which leave us with 100 kilograms times 9.81, which is the gravity, times the height, which is 2.5 in this scenario. This should leave us with 100 times 9.81 times 2.5, which would leave us with 2452.5. Let's write that down real quick. 2452.5 joules. Never forget the units because they're really important. Kinetic energy can be found by deducting the potential energy from the total energy. Doing 10,010 deducted by the potential energy, which will leave us with 7,557.5 joules. Part A of this demonstration is done, with part B being left, where the velocity of the roller coaster should be found at point A, B, and C. At point A, as the minimum potential energy equals maximum kinetic energy rule is applied, the kinetic energy at point A is the total energy, which is 10,010 joules. With 10,010 joules being the kinetic energy, we follow the same formula of half times mass times velocity squared, with the mass in this scenario being 100, and with the velocity being the unknown variable. To find this, we have to go down with the formula, where 10,010 is the kinetic energy. We have to get rid of the numerals in this situation to get left with 50 times velocity squared. To leave velocity squared on its own side of this equation, we divide 10,010, which is the kinetic energy in this scenario, by 50 to leave the velocity squared on its own side of this equation, which leaves us with 200.2, which ends up as velocity squared. To find out the velocity, we have to square root the velocity squared to get rid of the squared sign. To do that, hit on the squared button on our calculator, square root button on our calculator, and we square root the answer, which leaves us with three significant figures: 14.1 meters per second. At point B, as already demonstrated, the kinetic energy was 5,105 joules. So with the 5,105 joules being the kinetic energy, we follow the same formula of half times mass times velocity squared, with velocity being the unknown variable. With the mass being 100 times velocity squared, we are left with 5,105 divided by half of 100, which is 50, to equal velocity squared. 102.1 equals velocity squared in this scenario. With us square rooting 102.1 to find out the velocity, which ends up at 10.1 meters per second. At point C, already demonstrated that the kinetic energy was 7,557.5. 7,557.5 equals half times mass, which is 100, times the unknown variable velocity squared. As demonstrated before, we divide 7,557.5 by the numerals, which is half of 100, which is 50, to find velocity squared. 7,507.5 divided by 50 should leave us with, as according to the calculator, 151.15. Being velocity squared, square rooting that number should give us the velocity, which in this scenario is 12.3 meters per second. Thank you so much. This was me demonstrating kinetic energy and potential energy on a roller coaster on a smooth track, while finding out the velocity of the roller coaster as well as kinetic energy and potential energy on different points. Thank you very much.